So welcome back children. Let us now start with the worksheet number 1 of Gravitation chapter. So here we begin with the first question. If a rock is brought from the surface of the moon, so a rock is there which is located on the surface of the moon, its mass will change, its weight will change but not mass, but both mass and weight will change, or mass weight both will remain same. Children, as we know that the mass of a body always constant. Mass of a body never changes. It is fixed. But weight of a body changes due to the change in acceleration due to gravity or gravitational force. Remember children, the gravitational force or acceleration due to gravity on the surface of the moon is 1/6 of the sun that is on the surface of the earth. Okay, the value of acceleration due to gravity on the surface of the moon is 1/6 of the surface of the earth. Okay, that means acceleration due to gravity or simply gravity or gravitational force on surface of the moon is lesser as compared to the gravitational force on the surface of the earth. So, whenever a rock is brought from the surface of the moon to the surface of the earth, mass always remains constant because due to the change in force of gravity, okay, due to the change in gravitational force, the weight of the body changes because weight is equals to mg. Mass, even though constant, because of the change in g, weight also changes. So, mass will not change. Weight will change but not mass. So, mass will not change whereas weight will change because of the change in value of gravity or gravitational force. So, both mass and weight will change? No, mass will not change. Only weight will change. Its mass and weight both will remain same? No, because weight changes. So, the only correct option among them is option B. That is, its weight will change due to change in gravitational force. Whereas, mass always remains constant. Hence, option B is true. Moving ahead with the next question, SI unit of G, acceleration due to gravity. We have discussed that the acceleration due to gravity is SI, isn't it? It is measured in meter per second square. Okay. Acceleration or acceleration due to gravity, units of this is meter per second square. Hence, the correct option is option C, that is meter per second square. Moving ahead with the next question, third question children. SI unit of G is. So, what is the SI unit of universal gravitational constant? As we know that F is equals to G m1 m2 upon r square. M1 and m2 are the two different bodies. So, the value of acceleration due to G can be written as G is equals to universal gravitational constant is given as F r square by m1 m2. In SI system, force is measured in Newton, distance is measured in meter, distance square, meter square upon kg into kg is kg square. So, Newton meter square per kg square. So, option D must be true. Now, moving to the next question, children. Fourth question. Choose the correct statement of the following. So, among the four, one must be true. All bodies repel each other in the universe? No. Every particle attracts every other body in the universe. So, what force is it acting between any two particles in the universe? Attractive force is acting, but here it is given as repulsive force. So, it is a wrong statement. Our earth does not behave like a magnet. No, definitely. Earth attracts all the terrestrial bodies. That means as earth is pulling all the objects towards its center, so it has an attractive property. So, since it is having an attractive property, it behaves as of a huge magnet. Hence, our earth behaves like a huge magnet. But what it was given as does not behave is a wrong statement. So, it behaves as a magnet. Moving to the third option, acceleration due to gravity is 8.9 meter per second square. No, what is the exact value of approximate value of acceleration due to gravity is taken as 9.8 meter per second square. But here it was given as 8.9 meter per second square. So even this is also a false statement. Now moving to the fourth option, all bodies fall at the same rate in vacuum. Of course, in vacuum, each and every body are pulled with the same force because there is no reaction force, there is no opposing force. Suppose if the same body falls in the air means due to air, buoyancy force is acting, opposing force is being acting on that. As a result, there must be small slight variation in the weight is being observed. The gravitational pull is being observed because the bodies will be falling downwards and the opposing force is acting in the upward direction and the resultant force is being considered. Okay, net force is being considered. Whether it is taken in any fluid, whether it is air, water or any other fluid you consider, buoyancy force will be opposing the motion of the body towards the surface of the earth. So, but if you consider the same in vacuum, there is no opposing forces acting on that. Hence, all bodies fall at the same rate in vacuum. So, option D is true. Okay. So, now moving to the fifth question, children. If the distance between two masses is doubled, then the force between them will become. So, first of all, let us recall back the formula for force. What is the formula for force, children? Force, gravitational force is given by F is equals to G m1 m2 upon r square, where G is universal gravitational constant, m1 and m2 are the masses of the two different bodies and r is the separation between the two bodies. Since F is equals to G m1 m2 by r square, then the force between them, what will be the new force? Okay. So, first of all, let us consider the first force F1 as G is a constant for anywhere you consider the value of G always remains same throughout the universe and its value is 6.67 into 10 power minus 11 Newton meter square per kg square. So, G has a fixed value, constant value. So, its value never changes. Distance between the two masses be doubled. So, there is no change in mass. So, masses are kept as it is. Okay. Then G is constant. What we observed was G is constant. Masses are also constant. Only variable is distance between the two masses is doubled. Only distance is varied. Then the force between. If distance is changed, what happens to the force? So G is kept constant. The same two bodies are considered. So, masses are also not changing. So, M1, M2, G, everything is constant. So, we can conclude that the value of F is proportional to R square. Because G is constant, M1 is constant as well as M2 is constant. So, if you compare two different things, we can write that F1. Okay, if F is inversely proportional to this, then we can say that F1 is proportional to 1 by R1 square and F2 is proportional to 1 by R2 square because distance is being changed. So, first case, if distance is kept at the distance between the two bodies are R1, then force might be F1. If the distance between the two bodies is R2, then force must be F2. So, let this be equation 1 and this be equation 2. Now, let us divide both the equations and see what happens. So, dividing equation 1 with 2. This is better. Equation 1 with 2. What does it imply, children? 1 is F1 LHS. 2 is F2 in LHS. This must be equals to RHS part. 1 by R1 square whole upon 1 by R2 square. Okay. So, this after simplification, this will go up, then this will become R2 square upon R1 square, or it can also be written as R2 by R1 whole square. So very clearly we have F1 by F2 is equals to R2 by R1 whole square. But what is given, children? The distance between the two masses is doubled. So initially if R1 is R, then R2 must be equals to double of that is 2R. If R1 equals to R, then R2 equals to 2R. Substituting the same in the above equation, what you'll be getting is F1 by F2 is equals to R2 should be replaced with 2R and R1 is replaced with R whole square. So solving these two will get R and R gets cancelled, and hence the value of F1 upon F2 is found to be 2 square is 4, 4 upon 1. 4 upon 1. But you are asked to find out the value of F2. Cross multiplying these two, 1 into F1 is F1, 4 into F2 is 4F2. So F1 is equals to 4F2, or F2 is found to be 1 by 4 times of the F1. So how much is the force, children? It becomes 1 by 4 times of the previous force. New force is equals to 1 by 4 times of the previous force. Hence, the correct option is option 1, that is 1 by 4 times. So what is the value, children? Formula is F equals to G M1 M2 by R square. G M1 and M2 are kept constant, so F proportional to R square. Comparing these two, F1 is proportional to 1 by R1 square and F2 is proportional to 1 by R2 square. Dividing both the equations, equation 1 by 2 gives your R2 upon R1 whole square. But R2 is taken as 2R if R1 is 1R. Then simplifying, you'll be getting it as 2 by 1 as whole square is 4 upon 1. Cross multiplying, you get the value of F2 as 1 by 4 times of F1. So it becomes 1 by 4 times of the previous value.